This is a video for 149, how buff is your buffer. The problem states hydrofluoric acid is a weak acid. Suppose that you wish to make a buffer combining HF, hydrofluoric acid, and its conjugate base F-. First thing, we need to write out a chemical equation to show the reversible dissociation of H+. So I'll do this with water, but it's not necessary with water. And we know that this is a reversible reaction, so we're going to draw a double-sided arrow. And our products. Remember that H3O plus is the same thing as H plus. They're the same. Then we need to complete a Ka expression that describes this equilibrium, because later on we're going to be looking to solve for pH. So we know that we always put our products over reactants, so I'll show this as an H plus and F minus. So we're looking at concentration of H plus times the concentration of F minus over the concentration of HF, and our concentration is in molarity. Number 3. The Ka value for HF is 7.2 times 10 to the minus 4. Substitute in the value of Ka here that we wrote to calculate the molarity of H plus of a buffer solution that contains 1 molar HF and 1 molar F minus. So into my beaker, I've put 1 molar HF and 1 molar F minus. What is the pH of our solution? So we need our Ka expression and our Ka value. We know that our Ka value is 7.2 times 10 to the minus 4, and that is equal to the concentration of H plus, which is what we're looking for, times the concentration of our F minus, which is 1 molar, over the concentration of our hydrofluoric acid, which is also 1 molar. We can see here that the concentrations are the same and they cancel out. It's a 1-to-1 ratio. And so the concentration of our H plus is equal to Ka. And so our pH, we can take the negative log of our H plus concentration, which is 7.2 times 10 to the minus 4. So on your calculator, turn it on. Negative log 7.2. You can do the little e, or you can do 10 to the minus. I'll do it like this. And our pH is 3.14. Now it's saying calculate the pH of a buffer solution that contains 1 molar HF and 3 molar F minus. So we've put in more conjugate base. So you can say to yourself, what will that do to the amount of H plus in solution? How do I think it'll change the pH? If you can make that logical assumption or prediction in your mind, then the numbers might tell you something. So we again use our Ka value. Equal to our concentration of H plus, which is what we are looking for, times our concentration of conjugate base F minus over our concentration of HF. And here we have simple algebra. If we multiply by the reciprocal, that's the same thing as dividing by 3. So we do 7.2 times 10 to the minus 4 divided by 3. And we get 2.4 times 10 to the minus 4. That is our concentration of H plus. That's our concentration of H plus. Now we take the negative log of this. And we get, just do it the shortcut way, put the answer in, 3.62. That's our pH. And logically, you should be able to say to yourself, okay, I've added in more conjugate base, and bases are proton acceptors. So this base, F minus, is going to accept some of the H pluses that are in solution more so than this amount of F minus, because we've increased the concentration of F minus. And in increasing the concentration of F minus, we can increase the amount of F minus that is accepting H pluses, therein by decreasing the amount of H plus in solution and increasing our pH, or making it less acidic.